Okay, so in this lecture I'm going to be going over one particular circuit problem. And so the problem is the expression for charge that is entering a terminal is Q equals 1 over alpha squared minus, in parentheses, T divided by alpha plus 1 over alpha squared, all of that times e to the negative alpha t. Find the maximum value of current when alpha equals 0.5 per second. And alpha has to be in per seconds because time t there is in seconds. Okay, so here's your diagram here of your current going in, and we want to find the maximum value of current given this expression for charge. Okay, so the charge plot, well, what does that look like? It looks like this. It's plotted over a time span of 10 seconds, and this is what your charge plot looks like. Next, the expression for current can be derived from this relationship here, I equals dq dt. And so I equals d dt of your charge expression, which is the 1 over alpha squared minus t over alpha plus 1 over alpha squared, all of that multiplied by e to the negative alpha t. And so now you have I equals 0 minus e to the negative alpha t times d dt of t divided by alpha plus 1 divided by alpha squared plus t divided by alpha plus 1 over alpha squared times d dt of e to the negative alpha t. And so next we have I equals negative of all of this in parentheses of e to the negative alpha t times 1 over alpha plus in parentheses t over alpha plus 1 over alpha squared times e to the negative alpha t times negative alpha. Then we have I equals negative e to the negative alpha t times all of this in parentheses, which is 1 over alpha plus t over alpha plus 1 over alpha squared times negative alpha. Then that expression simplifies a little bit more to become I equals e to the negative alpha t times negative 1 over alpha plus t over alpha plus 1 over alpha squared times alpha. And so now we have I equals e to the negative alpha t being multiplied by all of this in parentheses, which is negative 1 over alpha plus in parentheses t plus 1 over alpha. And so within the parentheses we can see here that negative 1 over alpha plus 1 over alpha equals 0. And so we're left with I equals t e to the negative alpha t. That is our expression for current. And so let's go ahead and take a look at what that plot looks like. So this is our current plot. And again, just like the charge plot, it's plotted over a time span of 10 seconds. And this is what our current plot looks like. This is our current curve. And we can see our maximum value is somewhere around there, around 2 seconds. But going further into the analysis, let's go ahead and to calculate the maximum value, solve the equation 0 equals di dt for t. And so we have 0 equals d dt of t times e to the negative alpha t. And then we have 0 equals e to the negative alpha t d dt of t plus t d dt of e to the negative alpha t. And then now we're left with 0 equals e to the negative alpha t minus alpha t e to the negative alpha t. Next we have alpha t times e to the negative alpha t equals e to the negative alpha t. Then next we have alpha t equals 1, and finally we can see that t equals 1 over alpha. So when alpha equals 0.5 per second, we have a value for t that equals 2 seconds. So in our graph there, going back to that graph, it is exactly 2 seconds. But you want to go through all of your analytical techniques in order to get an exact, precise number for that. And if you didn't have that available, then at the very least you could do a very good approximation for this, and you can see that it's around 2 seconds. Or you can use the current plot here to verify what you got with your analytical techniques there. Okay, so next and finally, the value of that maximum current is I equals 2 e to the negative 0.5 times 2, which equals 735.7589 times 10 to the negative 3 amps, which is going to be approximately 736 milliamps. Okay, so going back to that, let's visually take a look at that. That looks to be 736 milliamps. So according to the plot as well as our analytical techniques, that all checks out just fine. Okay, so that is it for this problem. That is all that I have that I wanted to cover in this problem. Thank you for watching. Hopefully it was helpful, and have a nice day.